Countercurrents refer to the fact that exchange takes place between fluids moving in opposite directions. Tubular fluids in the descending limbs will flow towards the renal pelvis, while those in the ascending limb will flow towards the cortex, while multiplication means that the effect of exchange increase as the movements of fluids continue. Commonly, the ascending and descending limbs will share the same peritubular capillary. However, these two parallel limbs will have very different permeability characteristics. The thin descending limb is permeable to water, but relatively impermeable to solid, while the thick ascending limb is relatively impermeable to both. However, it contains the active transport mechanisms. There are three effects governing the countercurrent. First is the single effect. The single effect is actually following the permeability from the flow effect. The sodium and the chlorides will be pumped out from the ascending limbs via the active transport. So, the concentrations in the tubular fluids getting more and more dilute, while the peritubular concentrations getting more and more concentrated. Hence, this creates a concentration gradient surround the thin descending segment as well. So, the waters will move out by osmosis from the descending limb, and the concentrations in the tubular fluids will get more and more concentrated until it reaches the maximum at the deep concentrated urines. When it arrives to the ascending limbs, it actually helps the transport mechanisms of this sodium and chloride.
So now we discuss about the importance of the countercurrent multiplication system. So, efficiently reabsorb solute and water before tubular fluid reaches the deeper conjunctive tubule and collecting system. The system establishes a concentration gradient that predicts the passive reabsorption of water from tubular fluid in the collecting system. And the most important benefit from this system is to maximize the reabsorption of water and, of course,
antidiuretic hormone, also known as ADH, and it is a hormone that helps your kidney to manage the amount of water in your body, and it is also known as arginine vasopressin. It is made in the hypothalamus in the brain and stored in the posterior pituitary gland. ADH constantly regulates and balances the amount of water in the blood. Regulation of ADH. When dehydration occurs, ADH will be released. High blood osmotic pressure will stimulate the hypothalamic osmoreceptors. The osmoreceptor will activate the hypothalamic neurosecretory cells that synthesize and release ADH. The nerve impulses will liberate ADH from axon terminals in the posterior pituitary gland into the bloodstream. The ADH will affect the kidney, will retain more water, which decreases the urine output. The sweat gland will decrease water loss by perspiration from the skin, and the arterioles will constrict, which increases the blood pressure. When overhydration occurs, ADH will be inhibited. The low blood osmotic pressure will inhibit the hypothalamic osmoreceptors, and the inhibition of osmoreceptor will reduce or stop the ADH secretion. How ADH can affect the reabsorption? ADH, it will bind to the receptor on the cells in the collecting ducts of kidney and promote the reabsorption of water back into circulation. The ADH will stimulate the water reabsorption by stimulating the insertion of water channels or aquaporin into the membranes of kidney tubules. This channel will transport the solid free water through tubular cells and back into the blood. This will lead to decrease in plasma osmolarity and increase the osmolarity of urine. How ADH affects secretion? When hypothalamus detects too much of water in the blood, the pituitary gland will release less ADH. Thus, the kidney will remove more water from the blood. So, more water is lost in the urine, and urine will become more dilute.
Aldosterone effect towards reabsorption and secretion. Firstly, aldosterone is a steroid hormone which produced by the zona glomerulosa of the adrenal cortex in the adrenal gland. It plays a central role in the regulation of the plasma sodium, the extracellular potassium, and arterial blood pressure. Aldosterone also stimulates the kidney to retain sodium and secrete potassium, thereby indirectly influencing water retention, blood pressure, and blood volume. And this is the mechanism of aldosterone effect on the reabsorption. The aldosterone enter from the blood into the nucleus of distal convoluted tubule cell, and then the hormone receptor complex bind to DNA and alter the rate of transcription of specific gene. After that, the sodium enters passively through sodium channel. Then the sodium is then transported by the sodium potassium dependent ATPase pump. ATP here act as the energy source, and then the aldosterone increases the number of membrane of sodium channel. Lastly, aldosterone will increase the activity of several mitochondrial enzymes, and most likely resulting in the generation of ATP to drive the ATPase pump, so more sodium will be retained. There are three main purposes of this mechanism. Firstly is to increase the permeability of the membrane towards sodium, and then to increase the active transport of sodium out of the cell, and lastly to increase the energy available to the pump. Aldosterone is also part of a group of linked hormone which form the renin-angiotensin-aldosterone system. Activation of this system occurs when there is decrease in blood flow to the kidneys following loss of blood volume or a drop in blood pressure, for example due to hemorrhage, or decrease in plasma sodium concentration. Renin is an enzyme that leads to a series of chemical reactions resulting in the production of angiotensin II, which in turn stimulate aldosterone release. Aldosterone causes an increase in salt and water reabsorption into the bloodstream from the kidney, thereby increasing the blood volume, restoring salt level and blood pressure. Once the salt level and the blood pressure are corrected and the body becomes rehydrated, the level of renin in the bloodstream falls, and therefore the amount of aldosterone in the blood also falls, meaning more water is excreted into the urine. The renin-angiotensin-aldosterone system is an example of a negative feedback system.
After the aldosterone stimulation, it controls the reabsorption and secretion in the late distal tubule and cortical collecting duct. The aldosterone and antidiuretic hormone play an important role in reabsorption and secretion of substances. Substances that are being reabsorbed at the distal tubule and collecting duct are most of remaining water, sodium, chloride, and calcium, and bicarbonate ions. Substances that are being secreted at the distal tubule and collecting duct are potassium and hydrogen.